Good morning, friends. My name is Pankaj Dunga. Today I will be discussing with you energy equations. Now, you all know that the first law of thermodynamics for a closed system is given by dq is equal to du plus pdv. Now you can write this du as dq minus pdv. Now, if this infinitesimally small process which system is doing is reversible, then I can write this dq as t ds. So this du will be equal to tds minus p dv. Now, we have derived one tds relation which says that cv dt minus t del p upon del p upon del t at constant volume dv. This is plus minus pdv. So cv dt plus t del p upon del t at constant volume minus p into dv is du. So if I am saying that U, internal energy, is a function of temperature and volume, so I can write du is equal to del U by del T keeping volume constant dt plus del U by del V keeping temperature constant dV. On comparing these two, we will get del U by del T at constant volume is Cv and del U by del V at constant temperature, this will be equal to T del P by del T at constant volume minus P. So this is my energy equation. From here I can derive many things. For example, it is known to you that internal energy is a function of temperature when the gas is ideal. And for an ideal gas, we know PV is equal to RT. So on differentiating this equation with respect to temperature, keeping volume constant, I will get V del P by del T at constant volume is equal to R, or del P by del T at constant volume is R by P. On replacing the value of del P by del T at constant pressure in this equation, we will get del U by del V at constant temperature is equal to TR by P minus P. And what is TR? It is PV. So PV minus P divided by P. Sorry, it is volume here. Volume. So this will be PV upon V minus P. This will be P minus P is equal to 0. That means internal energy is not a function of volume. Now next task is to show that internal energy is also not the function of pressure. So how to do that? Let us say that internal energy, pressure, temperature, and volume, they are related somehow. They are related. And what I am doing here is I am keeping this temperature constant. So del U by del P at constant temperature into del P by del V at constant temperature into del V by del U at constant temperature, this will come out to be 1. This will come out to be 1. First identity which we have studied. Now, what I can write here is del U by del P at constant temperature is equal to del V by del U at constant temperature inverse into del V by del P, or del U by del V at constant temperature into del V by del P at constant temperature. This is del U by del P at constant temperature. Now you know, for an ideal gas, internal energy is not a function of volume, so it is 0. So the product will always be 0. That simply means del U by del P at constant temperature for an ideal gas is 0. Hence U is not a function of pressure. So if at the start I was saying that, let us say U is a function of pressure, temperature and volume, yes, they are related. But now I am showing that it is independent of pressure, it is independent of volume. So hence, for an ideal gas, internal energy is solely a function of temperature. Now second thing, I can do the same exercise for enthalpy also. Let us say, we'll do that. Let us say that dq is equal to du plus pdv. And we all know that H is U plus PV. So on differentiating it, you will get dH is du plus pdv plus vdp. Now what is this? This is dq. What is dq for a reversible process? It is tds. So dH will be tds plus vdp. Now one of the thermodynamic relations, it says that this tds is equal to Cp dt plus T del V by del T at constant pressure dP sorry, it is minus dP vdP. Yes. So if we rearrange them, we will get plus V minus T del V by del T at constant pressure dP. This is dH. So if I am saying that enthalpy is a function of temperature and pressure, so what I can write? I can write dH is equal to del H by del T at constant pressure dt plus del H by del P at constant temperature dP. So on comparing these, we will get del H by del T at constant pressure is Cp, well known thing, and del H by del P at constant temperature is V minus T del V by del T at constant pressure. This is also a well-known energy equation. Thank you very much for staying or connecting with me. If you like this video, then please do subscribe.